Pyth's theorem involves right-angled triangles. It gives the relationship between the three sides of a right-angled triangle. We memorise it as a squared equals b squared plus c squared, where a is the hypotenuse, the largest side, it's opposite the right angle. Two shorter sides are b and c. If you want to calculate hypotenuse, w, it's opposite the right angle here. W squared equals 12 squared plus 7 squared. Solve that equation, 12 12s, 7 7s, add them together. W squared is 193. W is the square root of 193. The answer of the calculator is not an exact answer, so you write it down and then round it as appropriate. In this case, W is approximately 13.9. So that's for a hypotenuse, square and add. When you want a shorter side, here the hypotenuse is 15 because it's opposite the right angle, so P is a shorter side. P squared plus 7 squared makes 15 squared. Take 7 squared off each side and you've solved for P squared equals 15 squared minus 7 squared. So it's handy to memorise that for a shorter side you square and subtract and you skip the first line. 15 15, 7 7s. P squared is 176, square root 176 in the calculator, and yet P is approximately 13.3. So for a shorter side, square and subtract. We now apply this in some examples. We want the perimeter of this shape. So to calculate the perimeter, add up the outside edges, but one of the edges is missing. Now this shape actually consists of a rectangle and a right angle triangle. There's a division line. A right angle. One side is 6. We can actually calculate this missing side here of the right angle triangle. 20 in height, and that's only 12 in height, so the difference is 8. That height must be 8. So that's 8 centimetres. It came from the 20 minus the 12. We've now got the two sides of a right angle triangle. We want to work out the sloping side. We'll label it x. It's a hypotenuse opposite the right angle. X squared equals 8 squared plus 6 squared. Follow it through, and x is 10. So that's Pythagoras' theorem on the right angle triangle here. Since that edge is 10, we can now get the perimeter. It's that length 20, that length 6, that length 12, and that length 10 added up. The perimeter is 48. So first it wasn't clear that Pythagoras was involved. We had to identify that. So that's an application of Pythagoras' theorem to shapes. There's a worksheet which you can download off the link in the description, or you can freeze the video. You have to calculate the missing edge A here, and therefore add up the outside edges to calculate the perimeter. Here's the second part of that worksheet. If you download the worksheet, it will have the answers with it, but here are the answers. So A is 15, add up the outside edges, the perimeter is 66 centimetres. There was the right angle triangle. What you would have to calculate before you could use Pythagoras is that 27 minus this 15 made that edge 12. That height is 9, just the same as this 9 here. And then you can use Pythagoras. A squared equals 12 squared plus 9 squared. Follow it through, and A is 15. So it's an application of Pythagoras' theorem. There are the right angle triangles in this shape, and there's a right angle triangle in that shape. So that's applying Pythagoras' theorem. This is the answers to the second part. missing edge 17, perimeter 60. There's the right angle triangle. There's the right angle triangle. There's the right angle triangle. There are right angle triangles. And there's a right angle triangle. So they all involve Pythagoras' theorem. Another application of Pythagoras' theorem is to calculate the distance between 2 points. If the points are plotted on the Cartesian axes, what you can do is construct a right angle triangle using the line joining A and B, that's the line you want to calculate, and drop a vertical and a horizontal to form a right angle, and you've got a right angle triangle. You can get the two sides by counting the squares here, 4 in the vertical. However, you can look at the y coordinates, 2 and 6, and realise it's a difference of 4. So you don't need to plot the points. You could do it without plotting any diagram at all if you use the coordinates correctly. 2 to 6 is 4, and the x coordinates is -5 to 3. Well, that's a difference of 8. So that would be 8 boxes along here. And now we've got a right angle triangle. We know two sides, the 8 and the 4. The hypotenuse is AB. So AB squared is equal to 8 squared plus 4 squared. So that's Pythagoras' theorem. 8 8s, 4 4s, follow it through. AB is the square root of 80. There's the answer off the calculator. That's AB is approximately 8.9 units. That's an application of Pythagoras' theorem to coordinates, working out the distance between 2 points. Here's another example. P is -2 4, Q is 3 -1. If we do it by plotting the points and drawing the triangle around the line PQ, you can work out the sides of the triangle. That's 5 units in the vertical. Now in the y coordinates it's 4 and -1. That's a difference of 5. And on the x coordinates it's also 5 because it's from -2 to 3. That's a difference of 5 units. So you don't have to plot the diagram if you can use the coordinates correctly. PQ squared is equal to 5 squared plus 5 squared. 5 5s, 25. PQ squared is 50. Square root 50 for the answer. Round off is appropriate. So that's the distance between 2 points. The worksheet that follows can be downloaded using the link in the description, and it will give the answers, or you can freeze the video. Here's the second part of that same worksheet. And here are the answers. If you construct right angled triangles around the points, and I'll put on the grid, you can see you can count the boxes, 2 along. Now that's going from x being 2 to x being 4, difference of 2 units. And then we are 6 units up. Y coordinate 5 to y coordinate 11 is a difference of 6. If you follow that through with Pythagoras, we'll find that the line is distance between the 2 points, the line is 6.3 units. Here's the second part of the worksheet. Here's the grid drawn in. There are right angled triangles. Again, that's 4 units if you count the boxes, but it's from x being -1 to x being 3, that's 4 units difference. And from y being -5 to +5, that's a difference of 10. So that is 4 by 10. 4 squared and 10 squared makes 116, and that's the square root of 116. So setting out the appropriate working, these would be the answers. Now the worksheets can be downloaded using a link. There's that worksheet. There's a previous worksheet and they have the answers. There's also a set of notes. So from the various videos, there's a set of notes that you can download. Hope you found this video useful. The next video will be on using Pythagoras' theorem in 3D shapes. Hope you found the video useful.